Bismillahirrahmanirrahim. Assalamu alaikum. My name is Ali Zishan and my partner named Kasan Nadeem. Welcome to all the chemical process technology. Due to lot of importance, we are going to give presentation on chlor-alkali industry. The chemicals in chlor-alkali industries are caustic soda, soda ash and chlorine gas. Lot of consumption of these chemicals are used in making soap, detergents, fibers, papers, fertilizer, explosive and solvents and petrochemical industries, etc. Now you can see chlor-alkali industry chart. In this chart we can see the flow diagram for the manufacturing of chlorine, caustic soda, soda ash and sodium bicarbonate. And how can we manufacture other material from these chemicals? Caustic soda is prepared by caustication of soda ash with lime. Only 10% sodium hydroxide solution is obtained by this process. Caustic soda are brittle and white solid. It is readily absorb water and CO2 from air. Caustic soda used in soap manufacturing, textile industries and petrochemical industries, etc. In manufacturing of caustic soda is prepared by the electrolysis of brine. Chlorine are produced at anode and hydrogen with alkali hydroxide at cathode. These three types of cells are used in manufacturing of caustic soda. Number one is mercury cell, number two diaphragm cell, and number three membrane cell. Raw material used for the manufacturing of caustic soda is brine and electricity. Energy changes is calculated in reaction by Gibbs equation. Energy consumed in electrolysis is product of the current flowing and the potential of the cell. Gibbs-Elm's equation represents the relationship between the electric energy and the heat of the reaction. Voltage efficiency. Heat of reaction is computed in Gibbs-Elm's equation to get energy is equal to 2.31 volt. Voltage efficiency is equal to energy of practically divided by energy of theoretically into multiplied by 100. Generally range from 60 to 75%. Faraday law 96,500 coulomb of electricity passing through a cell produce 1 gram equivalent of chemical reaction at each electrode. Current efficiency and energy efficiency. Ratio of the theoretical to actual current consumed is current efficiency. Current divided by area on each current act is current density. High value desirable. Product of voltage efficiency and current efficiency is energy efficiency of this. Decomposition efficiency. Ratio of equivalent produced in the cell to the equivalent charge. Usually about 60 to 65%. Diaphragm cell have very high decomposition efficiency and you can see fall. Cell types. Previously, mercury was most widely used. Health and environmental problems with mercury discharge in nearby water. Improved designing of membrane cell and cheaper purification technique have reduced cost and improved the efficiency. Dominate the field nowadays. Now you can see the diaphragm cell. Diaphragm cell contain a diaphragm made of asbestos fiber to separate anode from cathode. Allow ion to pass through by migration. Graphite anode and cast iron of cathode is used. Diaphragm cells have following advantage. Major advantage can run on dilute solution fairly impure brine. Dilute brine produce caustic soda of 11%. Disadvantage of this process consume lot of energy for evaporation. For 1 ton of 50% of caustic soda need 2600 kg of water to be evaporated. Some amount of chloride ion remain and is highly objective to some industries. Second method of caustic soda preparation is membrane cell. It semi-permeable membrane to separate anode and cathode compartment. Separate compartment by porous chemically active plastic sheets that allow sodium ions to pass but reject hydroxyl ions. Major advantages of membrane cell. Purpose of membrane is to exclude hydroxyl ion and chlorine ion form anode chambers. Membrane cells operate using more concentrated brine and produce pure, more concentrated product. Required only 715 kg of water to be evaporated to produce 1 million ton of 50% of caustic soda. Disadvantages of membrane cell. Membranes are more readily clogged than diaphragm. So many of the savings are lost because of necessity to pre-treated the brine fed in order to remove calcium and magnesium before the electrolysis. Mercury cells operate differently than other two. Cathode is a flowing pool of mercury and graphite anode. Electrolysis produces a mercury-sodium alloy, mean amalgam. Amalgam is decomposed in a separate vessel as you can see. Advantages of membrane cells. 50% NaH is produced with very low salt content, no evaporation needed. Disadvantages of membrane cell. Small loss of mercury to environment possess several problems. Now you can see the process diagram of mercury cell. Unit operations and chemical conversions involved in manufacturing of caustic soda. Brine purification, brine electrolysis, evaporation and salt separation, final evaporation, finishing of caustic soda and special purification of caustic soda. Brine purification involves the following steps: calcium, iron, magnesium compounds. Plug the diagram. Precipitation with sodium hydroxide is commonly used to remove them. Additional treatment with phosphate is required for membrane cells. Sulfate may be removed by barium chloride. Brine is preheated with other steams to reduce energy requirements. Brine electrolysis: 3 to 4.5 volt per cell is used, whichever method is adopted. Monopolar cells connected in parallel and low voltage applied to each cell. Bipolar cells are connected in series and high voltage is applied. In the step of evaporation and salt separation, membrane cell produce more concentrated caustic soda than diaphragm cells. Less evaporation and treatment needed in membrane cell. Mercury cell produce 50% solution and so no evaporation is needed. In final step evaporation, cool and settle 50% caustic may be concentrated in a single effect evaporated to 70 to 75% caustic soda using steam at 500 to 600 kilopascal. Strong caustic must be handled in steam trace pipes to prevent solidifications. It is run to finishing pots and other methods treating 50% caustic soda solution with ammonia, like countercurrent system in pressure vessels, anhydrous crystal separate from a resulting aqueous ammonia. Finishing of casting. Diatherm heated evaporated removal of water. Product is pumped by compressed pump that discharge the molten material into thin steel drum or into a flaking machine. In this step of special purification of casting, traversium impurity in 50% caustics are like iron, salt of sodium chloride and sodium perchlorate. Iron removed by treating caustic with 1% calcium carbonate and filtration. Sodium chloride and sodium perchlorate may be removed using aqueous ammonia. To further reduce salt content for some uses, caustic is cooled to 20 degree as shown in the following diagram. This is the process flow diagram for the purification of caustic soda. You can see how the concentration of the salt reduced in the caustic soda. Chlorine and hydrogen are produced in this process. Dry chlorine is compressed to 240 or 550 kilopascal. Heat of compression is removed and gas condense. Liquid chlorine is stored in a small cylinder. Hydrogen used in making other compounds like hydrochloric acid, hydrogenation of fatty acids and ammonia manufacturing.